Okay. Okay. So the last class, so we saw how to build up basic models using we saw Bayesian decision making process, how we incorporate data into and your prior beliefs and take decisions in life. And that is the foundations of machine learning that we saw. So we saw what was error, we saw what was the Bayesian risk minimization, and other than that, we also had introduced what is this, what applications do you have, and so on. For example, if you recall, we had done gradient descent and what is cross validation and so on. And we also showed what are the different ways you can take decisions using class conditional distributions and posterior distributions and using factoring for your beliefs and data. So today we'll be finally entering the heart of the background required for training all models in machine learning. That is understanding what is called maximum likelihood estimation and maximum a posteriori estimate or the MAP estimate. Okay. So other than that, we'll also see how they are related in linear regression. Okay, first of all, let's begin with a simple question and see if you all recall what we did last time. So we have been told that, say we have two data distributions, one data distribution like this. So where y equal to 1, class 1. Say this is some cats. And this is the distribution of dogs, say. These are remember, what do I mean by distribution and uh, what do I mean by distribution and so on? Say there are two features x1 and x2. So this is how, say, the features of dog look like. So they can be paw length and so on, right? So if any question at any point you have, you're not clear about something, please stop me and ask me. So this is what the data distribution looks like, right? So this is y given x given y, sorry. So this is called the class conditional distribution, right? If you recall from last class, right? So if this is the class conditional distribution, so you have the distributions of dogs and distribution of cats. So you should be able to say, let us put some intersection also between them. So just to make them look realistic. Yeah, so you may be telling me that you want to divide these two distributions, make a decision boundary as we were discussing last time. Say anything above this, we categorize as cats, anything below this, we categorize as dog, right? So this is what, whenever I mean distributions of data, I mean the feature distribution and y's are the labels of the data, right? So any questions till this point? Okay, so given the class, say you have two different distributions of data of their features. Now I ask you this question: what is the optimal classifier that you have? What is the classifier? Classifier as in there's nothing. What does the classifier mean? Classifier would mean probability of y equal to 1 given x. So you may ask me what is y equal to 1 and so on. Say, let us say we are predicting dogs or cats. So y equal to 1 means cats and y equal to 0 means dogs. So let us define this as g1 of x. Okay. So my question, I do not know what is y given x, right? That's what we have to find. So what is the if I can find out y equal to 1 given x, can you tell me what is y equal to 0 given x? That is what the dog's probability of cats given data, given feature. Can you tell me what would be the cat probability of dog given the feature? Like, yeah,
1 minus
why
v1
1
x.
minus?
G1 of X.
Yes. So it's by law of total probability, y my 1 minus, this is 1 minus G1 of X, which we have defined as, yeah. So this is not G1 of X, sorry. So this is the classifier because we have defined the conditional distributions as G1. Okay, clear? By law of total probability, we do this. Now I ask you the question, say you have non-equal priors. Say you know that the probability of dogs is, say in your locality or someplace, dogs are more common than cats. So you may say probability of dogs equal to 1 is not, probability of dogs and probability of cats is not equal. Say case 1 is the question I'm asking. So if the case 1 is these are priors, right? Priors that the probability that if you get a sample, what is the probability of the it being a cat, irrespective of the features of the data point, right? If there are more cats and more than dogs, then you will have more probability of y equal to 1, right? If more cats in locality, so you may have this. So they are saying overall that it is non-equal priors. Some 45, 55, whatever you were choosing as the prior. So my question to you is, how do I get the classifier? This is the classifier. So once I get the probability of y equal to 1, I already know the probability of y equal to 0, right? So if it is more than 50%, so you did not, nobody asked me. So can I ask you this question? So say I have this classifier that I have p of y equal to 1 given x, and this classifier says y equal to 1 given x as 0.6. So what should be your decision?
Y equals
It
to
is a
1
cat.
cat.
Good. Decision is cat. Nice. So now how do I find y equal to 1 given x? So that is the classifier we need. And it's very important. Maybe we are not going to touch upon the optimal classifier this time, but you may, when you see more details of generative models, it will be very important. Yeah.
Yes, so P, first of all, we will find P of y given x by P of x given y into P of
Okay.
y by P of
So you're
x.
saying, so x given y equal to 1 given into probability of y equal to Bayes rule, right?
Yes.
Into Bayes rule and find it. So now the numerator, now I know this is g1 of x into probability of y equal to 1, right? What is the denominator? So denominator, how can I write?
মৈনাকদা,
Yeah.
g1 of x টা তুমি ওখানে লিখলে না, কারণ ওটা হচ্ছে g1 টা হচ্ছে x given y1 তো।
Now I have defined g1 as the function that is giving me the value of p equal to p of x given y equal to 1.
আচ্ছা,
This is the
হ্যাঁ,
condition. I have defined it. So
ক্লাস
it's the
কন্ডিশন,
yeah, G is the class conditional density.
ক্লাস কন্ডিশনাল, আচ্ছা, সিমিলারলি g0, ঠিক আছে।
Okay, so how will I say the denominator? What will I say about the denominator?
P of x given y equal to 1 into P of y equal to 1.
What? Good. So I only know p equal, so p into p y equal to 1 plus
P of x given y equal to 0.
Into probability y equal to
Equal
0. Okay, so then what will this be?
G1x into P of y equal to 1.
G of x into p of y equal to 1 by g1x into p y equal to 1
plus 1 minus
g.
G1x. Oh, G.
No, it's
Okay.
not. No,
Okay,
see,
okay.
it's not 1 minus g. This is not g1, right? So this is g1 is the class conditional density. So
Okay, okay.
probability of x given y equal to 1 is not equal to probability of 1
Hmm.
minus probability of x given y equal to 0, right?
Hmm.
This is not, we can only say about the measure, the event that is being measured, not what is given, right? Yeah, we have discussed this. Yeah, so this will be y equal to 0. Correct? No questions, I hope. So now this is solving the case 1. So case B, what will I do? In case B,
When they are equal.
so say cats and dogs are equal in population in your region. So they will
Yes.
be, they'll just cancel out, right? If they're equal, I'll just write it in a different ink, or maybe this is, yeah. So maybe this will just cancel out. G1x right? So see, this is nothing but, yeah.
এই প্রায়ারটাই তো মনে হয় এভিডেন্স বলি না আমরা?
Evidence is P of X. This is the evidence, what is called. Evidence means what is the evidence of seeing the data. So if you draw the histograms here, you will see it is something like this. There's no evidence of data somewhere here or here. Right? Of X2. So more or less, more of the times, which is constant P of X, that is the evidence. But you in reality, what you understand is you get evidence from the data. So data is somewhere here that you get. This is the data or likelihood. Priors are known beforehand. The likelihood is learned from the data. That's the idea. Okay. So now that was a good warm up. Let's get in. Let's solve a different class of algorithm that is called discriminant functions. This is another way to take decisions in Bayesian learning or Bayesian decision making. So what does it say? So what we'll do is so what is going to happen is use the risk minimization using analytical probability distribution. So you have classes 1 to k and G1. So let's give me one moment. Yeah. So using the risk minimization technique. So what we have seen last time. So what here we'll try to do is we'll try to generate. So previously we did not have any functions, right? We did not have, well, last class we had only defined a risk of an action given an event, right? So given a class, what was the event? What was the risk of taking an action? But today we'll be formalizing it and seeing how to actually take those decisions. So a simple way is, say you have data X, right? If you have data X and you have k classes 1, 2, 3, k classes. So what can I do to classify into k classes is my question. So say cats, dogs, buildings, humans, and so on. So I can do something like this. So I can take k functions, separate functions, specifically for cat, pass X through it. For dog,
you're taking out the class conditional densities.
So we'll see what we are actually trying to do. So let us say that we define some functions g of x, right? And each of them gives you some number. Let us not confuse what numbers they are. Let us say they are proportional to some probability of being in that class, being in class I. Okay, let us for the time being assume this. So if they are all proportional to the same thing, then what can I say? I can do something like, if g1 of x, say gj of x greater than, or say let us take a concrete example, g cat of x greater than gi of x for all I. Then what decision can I take? So this is my comparison. I'll compare it like
It's a
this. Yes, so I can say that it is a cat. Clear to everyone? So what is this intuition clear? Then I'll go to the what is actually these G's are doing. I'm going to take K for K classes. Let's say we are to categorize K into K classes. Say some classes C1 is here, C2 is here, and C3 is here, C4 is here. And I want to categorize in between them, right? And I want to define some classes. So I'll take G1 and I'll pass, say I have a new point X somewhere over here. I'll pass it through all these GI functions, right? And see which of these classes give me the maximum number, right? Or the minimum risk, or like last time, which gives me the maximum likelihood, sort of a thing. Is it clear? We'll see what is actually happening, which is giving me the maximum number is sort of giving me more confidence that it belongs to that class. So this is the decision that I'm going to take. So now what are these GIs? These GIs are defined as the class conditional densities. Okay. Class conditional densities, right? Or even, so sorry, this is a posterior, right? Sorry. Is this okay? If I say that, what does this mean? It means that probability of given X, what is the probability of Ci or class being I? Is this okay? So now if I tell you Gi of X is greater than all Gj of X for all j not equal to I, then what is the class that it belongs to?
class I.
Belongs to class I. Belongs to I according to our model. Right? What is the model here? If I ask you, the model is
Gx is
G1, yes, dot gk. All these are model, the functions in the model, and then finally these give me numbers to take decisions, right? So if it is clear to everyone, can I proceed and show you how to do this thing? So this is nothing but, think of it this way: probability of X being in class I, right? This is how you represent that probability of class equal to I given data equal to X. Is it okay? Okay. So if that is okay, let's take an example and see. So this is the example that I have for you. So let us consider a binary classification task where C1 and C2 are cats and dogs. Class 1 and class 2 are cats and dogs. And you have images of these cats and dogs. So these images can be 68 cross 68 crossing or 64 cross 64 cross 3. Right? Normal color images. So this is the size of the image. My question to you is, can I generate a general category, a general discrimination function or discriminator function that will categorize between cats and dogs? Okay, so what have I been given? What is given to us? What is given? Or the data that is given to us? So data given to us is X and Y's, right? I equal to 1 to n. So you have n data points. Is that okay? Where X are images and Y is a label, say 0, 1. 0 for cats and 1 for dogs. Okay, so if that is okay, so what from the data I need to infer something. So what I will propose to infer is I'll be proposing that my model assumption or the model assumption that I'll have, or the functions that I'll have are this. So probability of C equal to 1 given X, I will let us assume is equal to some normal. So normal X is the variable. So I'll just wherever I write this X and I put a semicolon, it is the variable. Okay. So this is the variable that we have. X is the variable, mu I and sigma I. So I'll tell you what is this actually means. So this is a normal distribution I'm assuming. So this is my choice of the parameters. So X given C class equal to 0 is normal X, comma, sigma 2. So any questions, any doubts, please, before I go into the solutions, please ask me that the fun is here. After that, it is just calculation. No questions? I assume, so these are my models. These are my models. For a given X, the class conditional densities are defined this way. Okay. Okay, so if you are okay with it, tell me how will I estimate mu1 and sigma 1? First, I have to get the values of mu1 and sigma 1. That's my first priority, right? Am I audible? Can't you hear me?
Yes.
So what is not? Is it okay or some problem? Some problem with the explanation? Some doubts?
No. No, means we
Okay.
have to.
What do we have to?
We have to that probability of X such that class equal to 1. In that case, we have to fit a normal curve to that.
Normal to the data, not that.
Yes. To
The
that.
data is there. I have to get the mu's and sigmas. So it is very simple. We have already calculated sample mean and sample variance from the data. So if for univariate case, what was the, even for covariate case, we already know. So what is the expected value of X? So X is, so what is the X? Xi is of the dimension. What is the dimension of Xi? What dimension does Xi belong to? I already told this.
N cross 1.
So I told na 64 cross 64
64 or
cross
64
3.
3.
Oh, achha.
So there are 64 cross 64 cross 3 features that this image have. So Xi will be a long vector. X1, X2, dot, 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 X64 cross 64 cross 3. So let me just see how much is this number. 2 to the power 12 into 3, right? 64 square into 3. 12,228. Right? Or 88, sorry. 12,288. So these many numbers are there. So tell me what is the dimension, what will be mu and sigma. So we'll have to first understand for a larger dimensional space, what does our normal, we have only studied normal distributions in 1D, right? We have studied normal distribution of X as, what did we study this as? 1 by
Root 2 pi sigma e to the power minus x minus v whole square by 2 sigma square.
Okay, we have studied this. So now first assumption, say if we take, so multivariate normal. So multivariate normal means that same thing, but you will have contour plots like this, right? Your probability will decrease outside. So first, if I ask you if xi's were independent, then what would you say? What would be the probability distribution of X? If the xi's were independent, what would PFX be?
So it will be
multiply
the
the
normal whole to the power of that number.
Yeah, Ushmi?
you can multiply the PDFs like for the normal.
PDF, correct. So what is X? X is x1, x2, dot, 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 x1 to 28, right? 1, 2, 2, 8, 8. This is your X. And you have to estimate the density for this point, right? So this will be the probability of P of x1, x2, dot, 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 P of x1, 2, 2, 8, 8, right? All of the dimensions have been told to be independent of one another, so they will just product out, and you will have 1 by 2 pi sigma I is the first dimension. It will be just I equal to 1 to n e to the power minus xi minus mu I square by 2 sigma square, right? It will be just the product, and mu, considering mu's and sigmas can be different. Okay, is this clear? So this idea of independence is very crucial. Will also, it's not crucial in this question, but it will be crucial in the next topic we study. Is this clear? Hello? Okay. So in this case, you have x, x1 dot 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 xn, xi's are all normal mu sigma i's and independent. But if there is a correlation between xi and xj, what will happen in a picture? There is a correlation, right? So in a picture, if this pixel is high, the next pixel is also high, right? They're not independent of one another. There is locality in a picture, right? So if you take a photo and you have a sky in a pixel, the next pixel is also going to be likely to be a sky, yes or no? Sky pixel, blue.
Yes.
So you don't have this independence there. So there will be covariance of xi comma xj is not equal to 0, right? That's the main problem. In this case, covariance was 0, right? That's why we could, they were independent, so covariance was 0. So covariance of xi comma xi became sigma I squared. Others, all other covariances were 0 in that case. So in this, in a case where we have a dependent Gaussian distribution. So tell me, what is it? Is this distribution, this circle, is it independent or dependent? If I have x1 and x2,
Dependent.
Dependent.
is it dependent? I have sampled from Gaussian. They are not dependent, huh? Say this point. Once I sample x, I sampled y independently. You just try to sample x and y independently. You will see circular sort of a. You will see this as the PDF. This is your PDF. You will have most density in the center, and then it will decrease, right? Continuously outside as you move out. What does this mean? You sample x as normal 0, 1, and then sample x2 as normal 0, 1.
ও তুমি কন্টুর প্লটটা বলছো?
Yeah.
ও হ্যাঁ, ও তো মাঝখানে তো মিন, ওটা উঁচিয়ে যাবে, অন্যগুলো
So this is
flat.
a contour. This is, but if you had this as the normal distribution, so then they are dependent, right? As x increases, you're likely to have higher values of x2, right? Clear from the distribution?
বুঝতে পারলাম না।
Why do you have this tilt over here? The tilt is there because, so why here all the points could be equally likely everywhere on a circle. But here you see, as x increases, value of y is sort of changing according to it, right? As try to figure this contour plot.
মানে that the first one where you said that they are independent, there can I say that it is a multivariable standard normal, আর এখানে মিউ আর সিগমাটা আলাদা বলে একটু টিল্ট হয়ে
Mu
যাচ্ছে।
is same. Mu is still 0. Mu is 0, 0 of x1 and x2. But here you see, in any point on the x did not give me any idea about the y. It was equally likely. So if you had x here, your y could be anywhere along y.
হ্যাঁ ঠিক।
But here you see, if the x is far away to the right, you are more likely to have a higher,
larger y.
Yes. So they have a positive covariance. x1 comma x2 is greater than 0. You can just plot this in Python and see. Try to plot two normal distributions independently and plot it. And then give us covariance matrix. We'll see what is the covariance matrix, and then you try and plot it. You'll see this contour plots coming up.
মনে হয় skewness বলে না?
This is where, see, this is all the terms. This is skewed because your x is increasing, y x and y are dependent on one another. How is it coming? We'll see. So normally your z is, say we take z as z1, z2. So first let us recall the univariate case. Univariate. So I'm trying to mix things up. This was supposed to be done in probability, but just to mix things up, revise things, it's better to do it with the thing. So univariate. So what was, if x is distributed as normal mu sigma square, then how can I write x as? I can write x as mu plus sigma z, where z is normal 0, 1. Similarly, in multivariate case, X say is distributed as normal mu and sigma is the covariance matrix. I'll tell you what is. So let us understand what is a covariance matrix. So sigma is a covariance matrix means this is sigma 1 square, sigma 2 square, sigma n square, or sigma 1 square, sigma 2 square, sigma n square, right? So these are your variables x1, x2, xn, x1, x2 dot xn. So the ijth term will be, what will it be? Covariance of
sigma xi xj.
So covariance of xi xj, right? Is it clear to everyone? So sigma is a symmetric matrix. Why?
Because covariance of xi xj is equal to covariance of xj xi.
So all those properties, eigenvalues and eigenvectors will hold. You'll see this in PCA and so on. Okay, so X we have seen. So how do you get this formation? We get it this way. So X is equal to, say mu is a vector again. How many dimensional vector? Let me not write n, let me write d. So mu belongs to Rd, right? Correct. So X is a norm. X is normal. If X is d-dimensional, then mu have to be d-dimensional. It has to have n components like that we saw here. Expected value of x1, expected value of x2. Yes or no?
We accordingly ওটা তো add হবে আর
And we will have a mixing matrix. We'll see what is this mixing matrix. And Z is, if you write the Jacobians, you can get the actual formation. Z is Z1, Z2 dot ZD. Zi's are normal 0, 1. Okay, again with normal 0, 1, I have made this because I know only normal 0, 1s. And this A is found to be sigma to the power half, and does not mean that you make every root to be half, every number to be half. What does this mean? Sigma half into sigma half is equal to sigma, right? This is what it means. Or A squared is equal to sigma. This is how you solve for A. Okay. Is this okay with everyone? This is exactly as similar to this, right? Mu plus sigma Z. Here sigma is analogous to sigma squared. I'm not going into the Jacobians because you're not following this only, but Jacobian is very simple. You can just write each equation and just write the Jacobian, and we'll do transformation of random variables. We'll see what to do. But are you getting the idea? So A is the analog of in a continuous case of sigma. Sigma was a single covariance as a what is it called? A standard deviation. So A is the sort of the standard deviation matrix. Is it okay? And it mixes all the Z's.
সিগমা হাফটাও তো মনে হয় সিমেট্রিক হবে
Sigma half into sigma half is equal to sigma. So you can take transpose. It doesn't. So A will have to be symmetric.
yes
By definition. You take transpose on both sides. You'll get sigma half to the transpose squared is equal to sigma. So this has to be sigma half. So, but that is not a topic of discussion. Is the idea of making a normal is an n-dimensional distribution clear? So A gives you the is the covariance matrix. A is the standard deviation matrix. You can sort of think about it. If they are independent, it exactly boils down to a covariance matrix or a standard deviation equation. So
আচ্ছা
here
যে
what you, yeah,
কনসেন্ট্রিক সার্কেলস গুলো এঁকেছিলে ওটাই কি জেড এর ডিস্ট্রিবিউশনটা?
that is Z, yeah, that is Z. Any Z will be a sphere, na? Z's
হ্যাঁ
are, you just plot it, na? In Python, you will plot it, you will see how does it look like. Plot these points using matplotlib and see. Anyways, I've given you a homework to do that, which will be, it will come up. So any normal mu sigma can be written as mu plus sigma Z, where mu is the, so what is mu? This is expected value of x1, expected value of x2, dot dot dot, expected value of xd. They're all individually random variables, yes or no? Mu is the expected value of all these numbers.
yes
And sigma is the covariance matrix. So sigma ij will be covariance of xi comma xj, right? So that is it clear? So these are the, this is how you will estimate mu and sigma. Is it okay? So you will have data in this form, x1, x2, dot 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 xd. So if I tell you what is mu I, what will you say? So your data is in this matrix form, right? So d-dimensional data, and you have n data points. So what will be xi? What will be xi? Expected value of xi or mu I? Right, from the data you cannot tell me. Dimension 1, dimension 2, dimension d. Data point 1.
ওই যে summation I.
So first, others, how will I estimate this? Do I have the actual probability px? Is it, do I have this? So normally this is xi p of xi x dx, right? This is expected value, yes or no?
yes
But do I have that, have access to the probability distribution?
we have assumed it to be normal na.
P of x, do I have distribution of P of x? P of x I don't have. In machine learning, P of x is never there. P of x is the data distribution. The data is, I showed you something like this. Do I have the closed form solution for Px? What do I have from Px? This matrix I am showing you, you're still not.
আচ্ছা px টা তো I can estimate কারণ px such that
No,
c
no. Px is the data distribution which is unknown. And that is the problem of the entire machine learning. If we knew Px, then so it's solved. We can just plug in the values. Instead, what do we know? We know x1, x2, xn samples from Px.
কোনগুলোকে স্যাম্পল বলছো তুমি?
This is a ridiculous question. So you see this matrix, what do you, all this while I told you the first question was you have cats and dogs, images of cats and dogs, right? So
yes
what is the data distribution? Images, the image of cats and dogs.
হ্যাঁ
But do you have the distribution of cats and dogs yourself, like the number, the probability distribution distributed as normal mu sigma, and you know the distribution? Do you know that?
না
Is it given to you? What is given to you then? This data, this is a
the cats
Huh?
Probability of only the cats is given.
How only cats is given? Nothing is given to you. You only data points are given to you. Look at this matrix. Let us write this matrix again. So say data 1, data 2, data 3, data n. And each of them are d-dimensional. These are the data. This is known, you know. I don't know what is the issue with this. You know D1, right? You will be given that training data that you call machine learning. You'll be given some images of cats, and there will not be distributions. There will be numbers, right? There will be a sample from a distribution. So if I give you, say I toss a coin and I get heads, comma, tails, comma, so on. So do I get Bernoulli P or do I get heads, comma, tails, and so on?
No, from there I estimate Bernoulli P.
That's what I was saying. You have to estimate P of X. You don't know P of X. You know only data from X.
Yes.
So you cannot calculate this. Can you calculate this? P
No.
of X itself is not known.
না এটা তো নেই.
So you know, what you know is by law of large numbers, we showed this. This is why we showed this rigorously that time. Is this clear? So you will take the average of this column, and you will get mu I, right? Average of that column will give you the mean of that feature, right? There are D features, you will get D-dimensional mu i's. Okay. I won't ask again and again. So what would mu the vector be in form of in a matrix notation? This will be 1 by n summation of di I equal to 1 to n. Right? They are all d-dimensional vectors, right? Is this clear?
হ্যাঁ.
So all the features will have a mean. That is the mean of the features, right? So from the data, you will have the mean of each feature from this matrix on the left. Each of the column is all the features that you have, right? No, I don't understand what is the problem with this. So data. No, I can't even think what to do. You're not even asking, how can I clarify? What is DI? Just tell me what is DI. I have written DI here. If you're following, please tell me what is DI. What is DI? Again, after telling everything, now you don't know what is DI. Again, so if you are not comfortable with D, tell me that you have not written D, X1, X2. No, I'll just breeze over. Is this okay? What are XIs then if they are not comfortable? What is XI?
Feature and DIs are all those data points.
XIs I have written as d-dimensional vector.
Like one image.
Xi is the ith image. Is the ith image. So xi1, xi2, dot dot dot. So if I'm writing I on the top, these are the data points, and denominator yeah, I think I was disconnected. So xi from 1 to d, these are my features of the image I. So for each feature, I will have n images, right? So I take the mean of that. Similarly, if I tell you to tell me what is the standard deviation or the covariance of I and j, what will you say? Xi, xj. So anything in the subscript. So just to be consistent, I'll write it in the numerator. Okay, so I have, just to be consistent, I have written the numerators to be. So again, I am clarifying x I j is the jth feature of ith data point. Okay, is it clear now? Anything in the subscript is the feature, anything in the superscript is the
Data point.
yeah. So if I tell you what is the covariance between xi and xj, what will you tell me? Covariance is defined as expected value of xi minus mu I into xj minus mu j, right? Yes or no? Okay. We defined all this in probability and statistics.
Yes.
So now how again I do not know probability of x comma y, right? Do I know the conjoint distribution required to calculate this? For the same reason, I do not know p of x. How will I estimate this? How will I estimate this? Leave it. I'll just write it down. If you're not revising, what can I do? Okay.
From the samples.
And mu's I will get from the samples again. So just to be clear, we did 1 by n minus 1, if you recall, just to have an unbiased estimator. So then, as a matrix form, directly how can I write this? This is I comma j.
X minus 1 by n minus 1, x minus mu transpose x minus mu.
But that is a single number. X minus mu into X minus mu transpose will give me the matrix.
Yes.
Summation over I equal to 1 to n. Clear, everyone? So I'll get mu and sigma. If I am given data, I will get mu and sigma in this way. This is the idea. So everyone will have a covariance, everyone will have a mean, and I'll get the data. I'll get the required mu and sigma by taking the sample mean and sample covariance. Clear? If it is not, please go back and see. Now I have estimated the parameters. Now I will have to find the decision bound. Yeah, ask.
তো এটা তুই আনবায়াসড এস্টিমেটরটা আউট করলে তো 1 by n minus 1 করে।
Yeah, I could have used 1 by n also. It didn't make, if n is large, it doesn't make a difference.
ওই greater than 30
I don't know. All those things are heuristics of people who don't understand statistics. For me, n large means n infinity. Okay. So I know mu and sigma. So now first thing is p of x given class equal to 1 or class is equal to cats or class that is represented as 1 here. Then what will this be? Normal, x is the variable, mu1 and sigma 1, right? And how will I calculate mu1 and sigma 1? Similarly, the cats, this is the dogs. How will I calculate mu1 sigma for specifically cats and specifically dogs?
Yeah, so mu1 I will take summation of all those x1k k
So
equals.
everyone, do you follow? So these equations will give me the mu's and sigma, right? Yes or no?
Yes.
These are the two equations that will give me mu and sigma.
It will give me mu and sigma. Yes.
But how will I get the mu and sigma for cats and dogs separately? In my data, I'll be jumbled up and I'll get my data will be x comma y pairs, right? Y can be 1 and 2 anything. But how will I get mu1 just for cats and just for dogs separately?
I'll separate out all the samples which belong to one and separate out all the sample will belong to two.
Only cats will be sent here and dogs will be sent here. Cats and dogs will separately be used to compute the class conditional densities. Okay, so once you have calculated this, what is gi of x? Gi of x is probability
N
of c equal to 1 given x, right? Everyone, this is what we defined g of I, the discriminant function as.
মুইনাকদা g of ix তো এইটা ছিল না, g of ix তো ছিল x such that c equals to I go.
I don't understand what you say.
g of ix তো তুমি ডিফাইন করেছিলে x such that c equals to I মনে হয়। ও আচ্ছা আচ্ছা ঠিক আছে।
I told it's the posterior distribution.
Fine.
Simply g of I means the probability that it belongs to that class. I have not represented it as p because I'll show you why. I will not use. So just for a note, if you use the Jacobians and compute the densities, you will get this as the density. I hope this must be by heart for everybody. And please go back and see the one that I did last time. I have already used Jacobians and shown you how to transform random variables in multiple dimensions. Not very important for UG, that's why I've not done it here, but to the power d by 2 sigma to the power half e to the power minus half x minus mu transpose sigma inverse x minus mu. So do you see a similarity here between the one that you learned in single dimensional and multidimensional? Do you see a similarity?
Yes.
What similarity do you see?
Instead of sigma square, sigma is there, and instead of and all those x
No,
minus u that they
sigma
have.
square 1 in the numerator, and you have exactly that. You had x minus mu whole square, so that's what you have. You have a quadratic, but you cannot divide by a matrix, so you take the inverse. Right? You cannot divide by sigma, a matrix. You cannot divide by a matrix, that's why you take the inverse. This is a quadratic we discussed last time. If sigma is equal to identity, it goes down to this, right? A normal case.
X transpose
Okay.
Ax.
Hey, x transpose Ax. Where did you see x?
না ওই তো মানে সিগমাটা আই হলে
It's a quadratic, yeah. And this is the determinant of sigma because it is a division, so it has to be a determinant to the power half. That's the idea. So your homework is find it for a d-dimensional independent d-dimensional IID normal 0 ones. Just put, so if you have a d-dimensional IID normal IID distribution, which like that is z1 z2 dot 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 zd, all are normal 0 1. What is the distribution of pz? Your homework. So now tell me, so how will I get p of c equal to 1 given x? What do I have? I have x given c equal to 1, right? From the data. How will I get p of? Yeah.
so into p of x by p of c equal to 1.
So this is proportional to x given c equal to 1 into probability of c equal to 1. Right? So I'll
Yes.
just, for the sake of simplicity, I'll just not write equal to, it's just too much notation. Similarly, g2 of x will be proportional to probability of x given c2 into probability of c2, right? Correct? So now you can just, so since you see exponents over here now, what is easy to do? If g1 of x is greater than g2 of x, do you see log of g1 of x is also greater than log of g2 of x? Do you see that? Hello, am I audible?
Yeah, log to increasing function সেটা হবে.
Log is an increasing function. Okay, so now for simplicity, I will take log. So now I will write G1. So G1 had to be some proportional to this. And it had to be proportional to, see, G2 had to be proportional to this. This is why I wrote G1 and G2 separately. They need not be just probabilities, but scaling of probabilities. But that has to be consistent scaling. So I will define G1 of X as log of probability of X given C1 into probability of C1. G2 of X as log of X given C2, C2. So this will help me in calculation. That's it. So this will give me. So now if I say G1 of X minus G2 of X greater than 0, what will it mean? What will I just take a decision about?
ও আচ্ছা, এটা হবে ln of
No,
p of
if G1 of X is greater than G2 of X, what is the decision?
classify as 1.
To classify 1. As the probability of 1 is greater, else you classify as 2. Right? False. Okay, so let us calculate this one. I'll just I'll just calculate what is G1 of X then. It's log of P of C1. So C1 is the prior, right? We do not know yet the priors, right? But we'll keep them. Is it okay if I keep them? What else will I have? What is log of X given? Tell me, what is log of P of X given C1? Anyone?
Log
If
of
you're
p of
following,
C1.
what is log of X given C1? What is the value?
Ln of p of X given C1.
I have defined this very clearly. It's a normal 0, 1 normal mu sigma distribution and so on.
ও আচ্ছা, ওটা তো
Not no more acha. I just want to. This is you can't put the values. Then what can I do? Once I put it, everybody can see. Okay. Is this clear? Okay to everyone? So someone else, what is G2 of X? This is a constant. I can just remove it. Any constants can be removed. Well, what is G2 of X?
ln p of C2.
Yeah.
Then the same thing can be like sigma 2 1.
Okay. So I subtract these two. What do I get? I get log of P of C1 by log of P of C2 plus log of sigma 2 by sigma 1 half minus half Is this clear? Now I will show you that this is true by taking a special case. Say sigma is equal to identity matrix, sigma 1 equal to sigma 2, and you are just using mu's to take decisions. This is, say you do not have so much of computation power. Sigma calculation is difficult, right? All the n square you have to calculate. They calculate the inverse matrix and so on, right? Calculate determinant and so on. So say I assume sigma 1 equal to sigma 2 equal to I. So then what will be my and? I assume P of C1 equal to P of C2. These are equal priors, I assume. then what will be my decision boundary? Or G1x minus G2x. What will be G1x minus G2x if sigma is equal to identity?
ওই এই জায়গাটা জিরো হয়ে যাবে, একটা second term will become 0, so it's
Sigma no, the determinant of sigma 2 is equal to determinant of sigma 1 is equal to 1, right? For identity matrix. So this becomes 0, and then what happens to the next term?
minus half, we both become equal, become I, therefore it is x minus mu2 transpose x minus mu2 minus x minus mu1 transpose x minus mu1.
So what does this mean? If this is greater than 0, it means that so this is your mean mu1, and say this is your mean mu2. It means that this point belongs closer to mu1, right? In terms of mean. Yes or no?
Oh,
This is the distance.
একটা Euclidean তো ডিস্টেন্সটা।
Euclidean distance to the mean of the first distribution is lesser, so you take a decision. So very often in very simple systems, this is what is done. You take the mean, see the minimum distance, and then classify. This is also one nearest neighbor classification. We'll see. Okay. So, and G1x minus G2x equal to 0 is this is the decision boundary, right? Here you cannot take any decision, right? Along this curve, because both have same probability, right?
Yes.
This is called the decision boundary. So your homework, please solve it. Once you solve it, you'll feel so nice about this question, about this type of model. So the question is, and you have to solve it first in paper and then write it a code in a computer to actually have good visualization and understanding. So you have means and sigmas given for two distributions already given. You don't need to calculate also. Okay. You are told to find the decision boundary. First, find the decision boundary. How will you find G1 of x minus G2 of x equal to 0, right? Yes or no?
Yes.
And then you have to plot the two distributions as contour plots and plot the decision boundary in a 2D space. And it's a 2D graph, right? X1 and X2 are two features here. Okay. So this is what you have to do. Try it. I have done it for the general case. Try it for the special case and write this code and show it. Now, why was I talking about all this in so much detail? This is because we did not have access to any data. So now we'll try to understand how do we estimate these parameters without just assuming things like discriminant functions and so on. Let us take it a more general step, which is applicable to all models, not just assuming that the class conditional distributions have to be normal distributions or a particular form, right? So here where we introduce maximum likelihood estimate. So what is likelihood? If you remember from last class, what is likelihood? Likelihood was the probability of x given y equal to I, right? This was the likelihood of the data that we had. Okay, so now in MLE or the maximum likelihood estimate, we do not know the distribution as such, but we want to learn the distribution. It can be in some form or it can be some. You can be some closed form and you want to learn the parameters of the distribution. It can be neural networks. You will want to learn the weights. We'll see them in as we go ahead. It can be anything. So it can be either an explicit distribution or an implicit neural network based distribution. Both will you can solve using maximum likelihood estimation. So the idea is you are given. So in reality, again, remember P of X is not given to you, not known. What is known to you is the IID samples, right? Samples from the data distribution, right? You know X1, X2, and so on. X1, X2, Xn. Right? Just to maintain consistency, let me write X1 on the numerator. Is it okay? There are IID samples, and you want to estimate a model so that you want to fit this estimate. So the idea, let us understand this. So you have X1, X2, dot, Xn. Right? So you have data like this. And you have a parameter, say theta. Say a parameter theta. This on the y-axis is the probability of explaining the data, whole data. This is the whole data set given the parameters theta. Say you have a graph like this. So can you tell me what is the optimal theta that you would have? This is called the likelihood. And this is the parameter. We'll see how is it learned and so on. So what will be the best parameter? The best parameter will be that parameter that maximizes the likelihood, right or wrong? Theta star, best parameter, as it explains the data the best. Explains the data the best. Right? It explains the data the best. Therefore, it's a right. Therefore, it's the maximum likelihood estimate. Okay. So this is your theta star. So, but now what do I mean by this theta star? What do I mean? So I mean is X given theta. What I have is the model. Is the model or is the model likelihood? What do I mean by model likelihood? It is the probability that the data came from a distribution with parameters theta. Parameters theta. It is the probability that the data came from a distribution with parameters theta. So what is the best theta there? The best theta is this that maximizes the probability. Yes or no? Is it okay? Any questions? Okay. So how can I learn theta? How can I learn theta star? What is theta star? Can you tell me from the figure? You can learn theta star. Yes or no? This is the likelihood, and if you put the log in front, it's called the log likelihood. Both are same. You see, it's called log likelihood. Is this okay? Okay. No questions. So I'll not go into then divergences since you're not following this. Let us understand this in a simpler way. So if X is the data set and theta is explaining that, so can you tell me X was X1, X2, Xn, given your theta. So what can I write this as? Remember, Xi's are IID samples, or Xi's are IID random variables. Then what can I write? P of X given theta as. So recall X is the data set, capital X, and X1 to Xn. X is the data set, and X1 to Xn are the data points. Right? So I'm asking you, what can I write this log of Px given theta as? Any ideas? Can I write this as I equal to 1 to n probability of xi given theta?
Yes, because they're independent.
They are IID. Good. And they are independent and identical, right? Independent and identical. So when people, if you don't interact, it becomes, I don't understand what I have conveyed or what I have not conveyed. It becomes, if it is a monologue now, it becomes very difficult to teach in an online setting. So what will be log of this? Log of this will be summation of.
Summation of log of P of Xi given theta.
This is why you take log. It becomes simpler. Products are difficult to calculate. Sum is very simple, right? In computer also, you can easily compute. So your theta star is nothing but the argmax of theta. Let's find out. Let's take an example. It will become very crystal clear. So if you understand the example, I'll come back to what I mentioned. So I have some books I have mentioned. This one I have mentioned. The data set given xi, right? The linear divergences and all. I will explain if you want me to, because you're not following. Let's see if you follow. So this part is clear, right? So theta star is the argmax of theta log of P of X given theta. Correct? What is given theta, you may ask me? Theta is the, remember, theta is the, Washmeet, what is theta? Parameters that explain the data, right?
Hmm.
So let us take, see, abstractly, it's much more difficult to understand. Let us take an example. Say you have y1. I'm writing this in the subscript, but just ignore me. So yi's are real numbers, or they are between 0 and 1. 0 or, is it 0 or 1? Okay. Yi's are 0 or 1. Now, what am I saying? I am saying that this yi are distributed as Bernoulli theta. Okay, do you agree with me? Can I write this way? In statistics, I used to write y given Bernoulli theta in this form, right?
Yes.
Just I think, yeah, this form. But I can also write the same thing. What I meant by given theta is this: yi given theta is equal to Bernoulli. Yi is the variable and parameter is the theta, right? This is what I meant by given theta. Okay. Clear? So yi is a sample from some Bernoulli distribution. They are zeros or ones. Okay, zeros or ones. I am telling you to estimate theta. That in turn, when you estimate theta, you will get the model, right? You will get Bernoulli theta as the model. Yes or no?
Yes, sir.
So this is what I was representing as x given theta, right? Y and x, you don't confuse. Y is just a change in name of a variable. I did not write x here. Is it okay? Y1 to yn are the n random variables, IID random variables, sampled from some Bernoulli distribution. What are the outcomes possible from a Bernoulli distribution? 0 or 1, right?
Yes, sir.
So I will have some theta. Theta can be between what? Between what it can it be?
0,
0 and
1. It is a probability. So
good. 0 and 1. Bernoulli P is between 0 and 1. So you may have some graph like this. So this will give you theta star. Now you're understanding what I mean by maximum likelihood given a data point. Let us see. Now you tell me what will be y given theta then. So first you tell me what is your guess that what will be theta? Theta star. What is your guess? What is your guess of theta star? It is the number of times it lands heads, right?
somewhere in the middle half, like around half.
No, I understand, but if you say it is not a Bernoulli, it's not a bias point. It's a bias point, say. Then what will be your, if you're given the data head tail, what will be the theta parameter? Theta is the probability of
So number of
head,
heads by total trials.
so y summation of yi 1 equal to 1 to n by 1 by n, right? This is
Yes.
your hint. Good. Because heads are 1 and tails are 0, as we have seen in random processes. Okay. So this I can write as pi equal to 1 to n yi given theta. Do you agree?
Yes, yes.
So log of this will be, so this is your loss function that you want to optimize. Let us write it. So 1 equal to 1 to n log of yi given theta. Is this okay? And you want to get theta star as argmax of L theta, right? You want to maximize that? That's the objective. Okay. How will I maximize it? So first I will need to know what is P of yi given theta. What is it? So probability y equal to 1 given theta is what? What is the probability that y equal to 1 given theta? And what is the probability of y equal to 0 given theta? The Bernoulli distribution with parameters theta. X was distributed as Bernoulli P. What is the probability x equal to 1?
P.
Here, P of y given theta is distributed as Bernoulli theta, right?
Then it will be theta.
Good. It will be theta. This is 1 minus theta.
1 minus
correct?
theta.
So can I write P of yi given theta as theta to the power yi, 1 minus theta to the power 1 minus yi? I'll stop for 1 minute, and if you cannot still find the reason for this, I'll explain, or if you have found the reason for it, you can explain.
So if you just substitute y equal to 1, then we get the first value of that, and if you get,
Okay, yi equal to 1 means
then we
you
get
get
the
theta.
value as theta.
Yes, and if you substitute yi
Equal to 0, then we get 1
you
minus
get
theta.
1 minus. Very good. So you can compress this equation into a single equation. So now you tell me, now it should be very simple. What should be L theta? It will be 1 equal to 1 to n log of, so it will become yi log theta plus 1 minus yi log of theta, 1 minus theta.
1 minus theta.
Clear? Now I can estimate theta. Estimate. How will I estimate?
You can differentiate and then 0.
dl d theta and set it to 0. So dl d theta is summation of I equal to 1 to n yi by theta plus 1 minus yi by 1 minus theta, right? Minus. Correct? So I can write this as yi 1 by theta I equal to 1 to n is equal to summation of I equal to 1 to n Clear? So I can write 1 by theta as n by summation of I equal to 1 to n yi, or theta star as 1 by summation of I equal to 1 to n yi. Did we get the same? Is it clear? Any questions? Did we get the same output?
Yes.
No calculation, you can also take the derivative, second derivative, and show that it is less than 0, right? Since this is a maxima. Correct? Has to be less than 0. It's a maxima point. So argmax is this. Good. So let us take another example. This will be without taking a derivative. You are told that zi's, again 1D case, are between theta and theta plus 1. Okay. You're told that zi's are between theta and theta plus 1. And uniform theta and theta plus 1. Again, you are told to estimate theta. So what is probability of z given theta? It is uniform. Z is the variable theta into theta comma theta plus 1, right? This is how you write. Is the understanding slowly coming in? Is the general form slowly you are understanding the more general form more clearly now?
Yes, sir.
So z given theta is uniform z. Z is the variable, random variable, and theta plus 1 is the parameters of the random variable of the distribution. Okay. My question to you is, what is again P of z given theta? How can I write this as? Or what is the log of z given theta?
The summation of log of probability zi given theta.
Okay. Now my question comes, what is this going to be? So, or I can just say, for the time being, let's keep log out inside. I'll tell you why. It will be easier to calculate. Okay, this also is right. My question to you is, what are the values that this can take? So P of the product of I equal to 1 to n Zi. How can we get the values? So do you know that? You know this, right? Uniform AB, if x is distributed as uniform AB, then fx of x, or the density function px of x, is equal to 1 if x is between a and b. Yes or no? 0 otherwise? Or some constant 1 by b minus a, whatever. Yes or no? This is what your density looks like. Outside that, everything is 0.
Yes.
Okay, now you tell me, if it is really that, then what has to be mine? So what are the values it can take? So do you agree they can be either 0 or 1? 0 if only 1 Zi is greater than theta plus 1, or Zi is less than
Less
theta.
than theta.
Any of these two cases, theta and theta plus 1, if only one Zi is outside, then it will become 0, right? 1 if all Zi is between theta and theta plus 1. Do you agree?
Yes, sir.
So log of this will become minus infinity if only, or let me write, there exists an I such that Zi theta plus 1 or Zi less than theta, and 0 otherwise. So this is not the case we want. We want this case, right? The second case. Do you agree?
Yes.
Yes.
So how can I make it the second case? So I have data points Z1, Z2, dot, 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 Zn. How can I select theta? I have been told that they have to be between theta and theta plus 1. How can I select theta? Can you tell me? So do you agree that theta star, so theta min, is a solution if theta is equal to minimum of? Do you agree to this? If theta, if I, similarly, theta max 1 plus, let's take 1 and 2. Okay, the minimum of Z1 if I take. Do you agree? If this is theta, all the Zi's have to be between theta and theta plus 1. The minimum is here. If the minimum is Zi, since its Zi's have been sampled from uniform 0, 1, uniform theta and theta plus 1. If the minimum is set as theta, do you agree theta plus 1 and theta will contain all the Zi's?
Yes.
Similarly, if I take theta plus 1 as maximum of I Zi, do you agree that between theta plus 1 and theta again, it will going to contain all the Zi's? So let me just draw this. Say, for example, your samples, say your data was 0.5, 0.6, 0.8, 0.9, 0.92. Right?
Hmm.
What is the theta 2, theta 1 here? 0.5, right?
0.5.
So do you agree? So your likelihood is minimized because 0.1, 0.52 1.5, all the data points will lie between them, correct? Yes or no? This is 1 plus theta 1. Similarly, 0.92 is your theta 2. So do you agree? 0.92 minus 1, this is 0.08, negative 0.08. Between minus 0.08 and 0.92, all the data points will be contained. Yes or no? So all thetas between 0.08 and 0.5 will be valid thetas. Yes or no? So I am saying theta star is equal to max I zi minus 1 to min I zi. All numbers. Is it clear?
Yes.
How do you? Okay. So now let us recall the algorithm that we had learned last time. We had learned an algorithm called linear regression, right? So I'll show you how linear regression is also maximum likelihood estimation. Before that, till now, what were we doing? I'll just give you a small trick and it will be changed to this new form. What were we doing? We were maximizing till now. Till now, we were doing P of x given theta, right? Do you agree? Right? Yes or no? This was the likelihood function. Likelihood we were maximizing. We maximize the likelihood, yes or no? But there is a problem with this formulation. Can you tell me? It's the same as last time we discussed the Sally-Clark problem. What is your objective? Your objective is to infer theta given x, isn't it? You want to learn the parameters theta. Learn the parameters, right? Given data. Right? But tell me, if you have to learn the parameters, but you only know the likelihood, how will you do that? Yes or no? By Bayes rule? Am I audible?
Yes, sir.
So you have to learn the parameters. Till now you were trying to use the likelihood function to maximize the likelihood. Yes or no? So you were doing, so this was your data. So you are taking theta MLE as this form which maximum explained your likelihood. But if I tell you that I have a knowledge over the priors, I have a basic knowledge. I have a knowledge that in India there will be no snowfall. So I will take very low priors over snowfall, yes or no? And then you incorporate those priors and then infer theta, right? So this is the prior that we did last time. So that prior is being incorporated here over the parameters, prior or belief over parameters, right? So it is the prior or the belief over the parameters that we are interested in. So now how will I infer it? Now so if I take the log on both sides, what will I get? I'll get log of P of x given theta plus log of P theta plus some constant. This is a constant, does not depend on theta. Clear? So what is this? this part is the loss of MLE, right? Yes or no? This is the loss of the MLE, the map. This is what we did, right? In the maximum likelihood estimation, we maximize the loss of, maximize the likelihood of the MLE. But here we are going to jointly optimize the likelihood of MLE plus the likelihood of the data or the parameters, theta, priors over the parameters. So this helps us understand. So you see this graph over here. So if I have this idea over theta, so do you agree that P of X given theta into P of theta will change? And I will be incorporating both of them somehow. And I will have a new theta parameter, which is the maximum a posteriori. Maximum a posteriori. It's not yet appeared here. So yeah. So you will, so the blue line over here that I put an arrow, this is the beliefs over parameters. Okay. And similarly, I have P of X given theta available to me, which is the data distribution. So to estimate the map that I have, the maximum a posteriori, the estimate of the data, I will be multiplying both of them and incorporating both of these together. The idea is to incorporate beliefs with the data. Okay, so first thing we have already shown that theta star map is argmax of, so we showed it here. So theta star is equal to argmax of theta. So we already showed this. So I don't know why did it hang? Just one moment. Am I audible though? Hello?
Yes, sir.
Okay, but my screen has hanged, right?
I can see the screen, but nothing is happening. Like
No, I am showing the theta star argmax of theta.
no, that is not visible.
Yeah.
The graph is visible where I have written theta star.
Yeah, can you see now? I think I have to reshare. Is it clear up to what I'm trying to do?
Yes, sir.
I'm just trying to incorporate our knowledge of the priors. Till now, I was not incorporating the knowledge of the priors. Oh, what did I do? Okay, I think you can see my screen now. Not yet stable. So this is what we found. Okay, now my question is, you have to show that a linear regression is nothing but a map estimate with L2 regularization. And we will show this using a very simple technique. And we'll also show that normal linear regression is MLE estimate and regularized linear regression is your map estimate, which will give you the idea that we are incorporating this idea that what is the priors that we incorporated in linear regression? We incorporated the priors that the weights have to be small, right? Isn't it? So that's what we'll try to incorporate and see. So previously I had told you, so X is equal to W transpose X plus epsilon is a linear regression model, right? Which we showed that epsilon is normal 0, sigma squared. You recall we had, this was your line and everything that was the noise was making it go above and below the line. Do you agree? This was your linear regression model. So what was your, so now if this is the case, what is the distribution of y given x and w? Both are given. Then what is the distribution of? So these are the parameters you want to learn. you want to learn. So what is it? What is the probability of y given x? What is the distribution from this equation? I'll give you a simple hint. Say y is equal to a plus or normal 1 plus normal 2. Normal mu1 sigma 1 squared plus mu2 sigma 2 squared. What is the distribution of y then? We did it using generating functions. This was normal mu1 plus mu2 sigma 1 square plus sigma 2 square, right? If they were independent. Okay. So what will this distribution be? So what is the distribution of the W transpose X? Normal W transpose X comma 0. There's no covariance, it's a constant. Right? What will be then Y's distribution? Normal W transpose X comma sigma squared, right? Good. So now I know the distribution of Y given X comma W. What do I want to estimate? I want to estimate, what do I want? I want W given X comma Y. Do I want this or not? This is what I want.
Yes.
Because we want to estimate the parameters of W. So how can I write this as? I can write this as X, Y, W by probability of W, or sorry, X, Y. Correct?
You have written ln of x comma y comma w.
Oh, sorry, P of this. My question to you is, but I only know this distribution, right? Y
So
given X comma
P of y given x comma w into P of x comma w.
Good.
In the numerator.
So I can write of P of Y given X comma W into P of X comma W divided by P of X comma Y. Denominator, do you agree, is constant? It is a constant.
Yes.
Does not depend on W. Similarly, in the numerator, can I write P of Y given X comma W into P of W into P of X given W?
Yes.
This is also equal to P of X because X is independent of W. Independent
Yes.
of W. Because X you are inferring from the, so how are you inferring W? You are inferring them from, you're using X to predict Y. So your X is already data distribution. So it does not change given W, right? Idea is data distribution does not change given W. So what do I get? I get log of P of W given X comma Y is log of P of Y given X comma W plus log of P of W. Agreed? Yes or no? I just took log on both sides. And this is constant, so I can remove constants. Constants can be removed. Because I will optimize over W, right? So W star is argmax of W log of P of X given W plus log of P of W. Now I have these assumptions. So I know P of W. What did we take the assumption of P of W to be? They have to be small, right? You recall the assumption? W's must be small. So if I write the covariance matrix of W as 1 by lambda, 1 by lambda, dot, 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 1 by lambda, where lambda greater than 0, greater than 1. Will it ensure small w's or not? Where W is distributed as normal 0, 1 by lambda I, right? Yes or no? So for a small example, let us take normal 0, 1 by 10. What will it ensure? If W was sampled between normal 0, 1 by 10, what would it have ensured? This is 1 by root 10 is 1 standard deviation, yes or no?
Yes.
So 99% of the data would have been between minus 2 by root 10 to 2 by root 10, right? We know the 95, 65, 95 or 3 by root 10, sorry. Most of the data would lie in between this 99.9% according to normal distribution. So if I take a large W, I will be if I take a large lambda, I will make the lambda weights to be small, yes or no? In the ridge regression, we took that constraint, right? Since to deal with outliers, we took small W's. So that is being ensured by 1 by lambda times I. So let us put the values here. So what is this? 1 by 2 sigma 2 pi e to the power of minus, what is it? Tell me the distribution. So what is this going to be? Please, man, tell me. What is this closed form? 1 by sigma root 2 pi e to the power minus y minus w transpose x squared. Yes or no?
Yes, yes, yes.
This is the mean and this is the random variable. So if I take the log, what will I get? I'll get some constant log of 1 by sigma root 2 pi plus log of e to the power of minus y minus w transpose x squared by 2 sigma squared. Yes or no?
Yes.
And I will get log of some constant and e to the power of 1 by lambda. Sorry, W minus zero
by
transpose.
lambda.
Yes. So sigma inverse is what will be sigma inverse? Can you tell me? This I can write. Tell me.
The like lambda, like on the diagonal there will be lambdas.
Diagonals will have lambdas. Very good. 1 by lambda, 1 by lambda, 1 by lambda. So sigma inverse will be just sigma is this. Sigma inverse will be just, if it is a diagonal matrix, it will just
Lambdas.
flip the diagonals, right?
Yes, yes.
Because the products will be remaining of the diagonal and you will get identity. So now if you multiply these two, you get I. So you will get lambda times. So do you agree? You will get. So this term will become log of e to the power minus lambda times squared. Yes or no? Because every term has lambda, I can take lambda common. And you will have yes or no? So W transpose lambda I W. So lambda I'll take common. So I'll get y minus W transpose x squared by 2 sigma squared plus lambda times, or rather minus lambda times. This is your L of W, which you want to argmax, right? W star will be argmax of L of W. So let sigma equal to 1, right? So if sigma is equal to 1, then what do you have? You have L of, so you have L of W. Rather, let us write L cap of W W minus W transpose X squared by 2 plus lambda W squared, right? This is what you have. Now, if you have this, I have just removed the negative. So this is minus LW. So W star, do you agree, is argmin of L cap of W? minimum.
Yes, yes.
Negative, we have taken the negative.
Yes, yes.
So this is exactly the L2 regularized linear regression, right? So L2 linearized linear regression is nothing but a maximum a posteriori estimate with a diagonal covariance matrix where you are taking gamma lambda to be or the weights to be small. This is where it comes from. So now if I take, so this became MLE, I showed this. Finally, if I do not assume, so if I take priors P of W to be constant, right? Some constant priors, then this will go away, right? See, if W had constant priors, P of W given x comma y would have been nothing but P of y given x comma W would have been L cap of W is equal to WY minus W transpose X squared by 2. Right? And this here sigma is just a design parameter. You can take any sigma. This is not learned, so you can take any sigma. Just in case you are just not following why I took it equal to 1. So this plus 0, this term will not remain, right? So without the priors, it becomes linear regression, which is equivalent to maximum likelihood estimation. But since we took into account the small size of W's, it became maximum a posteriori estimation because we are using. So again, to the takeaway messages, we are using this priors. So if you can see, wait, it's not yet come to the screen. I'll just wait for a moment. Yeah, you're using these priors to help regularize your model. What does regularize your model mean? We regularized the model. We'll see in more in details. That is, regularization means incorporate priors to make model simpler. So you made this priors you incorporated. So now you have incorporated your beliefs and now you have used the theta star map. So once you solve these examples that I gave, it will be very clear. Is this clear? Is the map estimate clear? And how linear regression is a map estimate? Is that clear? Any questions? I'm waiting for questions. Please ask. Okay, so if there are no questions, so there is only a small thing that I wanted to do, but do you want to do it? It will take only 5 more minutes. I want to show you that maximum likelihood estimation is nothing but using a term that is called scale divergence. We have learned everything, but this will help us to understand how to minimize distance between distributions. It will take only 5 minutes or 6 minutes maximum.
Okay.
Okay. So we understood what is maximum likelihood estimation, right? We were by this figure. We saw that it is the parameter. We took the parameter that explained the distribution the best, right? Yes or no?
Yes.
But now, say initially when you start off, say you have to train the model, right? So say you have chosen a theta, and this is your actual data, right? This is your actual data distribution. Actual Px of x is the actual data distribution. And your P theta of x is this distribution. Or yeah, P theta of x given theta is this distribution. So how do you learn the theta? The idea is you learn the theta by minimizing the distance between these two. So what is the idea? The idea is, say you have two distributions, P is like this and Q is like this, which you can change by using theta, right? You can change Q using theta. So you learn Q. So now it is a different visualization. The visualization is you learn theta such that this distance is minimized, right? It becomes something like this, maybe. This is P of x given theta star. Okay,
Yes.
so this Q and P, I am trying to minimize the distance. Do you agree that at a distance from one another? But if I make them overlap, they'll have smaller distances. Right or wrong? And I have a
But
parameter.
we are making the overlap by moving the right graph only, right? We are not moving the px of x.
Yes, we are only moving. P of x is already given to us.
Yes,
We can only move Q theta of x. So we have to move Q theta of x such that they become similar to one another. Wherever Px is high, you must have Qx to be high. Wherever Px is low, you must have Qx to be low. So we do this by using a divergence metric. It is called divergence metric or distance between two distributions. Distance between two distributions. This will be very useful later on. So I just want to keep this in your mind. So say you have two distributions P and Q. They have PDFs Px and Qx. Then the KL divergence is defined as the integral of Px. I'll tell you why it is defined this way. Don't fall out. This is the definition. Is this clear? Or we can also write this as, can you tell me, Oshmit? What does this actually mean? Expected value of log of Px by Qx.
Oh, yes.
No, this is by Lotus. So these are the two equal definitions. Now, do you see one thing? If P equal to Q, then dKL equal to 0, right?
Yes.
But we have to show that because Px by Qx is equal to 1, then log of Px by log of Qx is equal to 0. Log of P by Qx is equal to 0, right? Now, if the log of 1 is 0. So now what do we have to show? If it was a distance metric, do you agree? dKL of P comma Q have to be greater than or equal to 0, where minimum is 0 when they exactly match. Right? Only when they match will they be 0, right? We'll show why it is, but this is a property we would like to have, right? Any questions on equality of P equal to Q? And anything not equal will have larger distance. That should be the characteristics. Okay. So now let us show how does this happen. So if you look at session 9 of my previous course, that is JU Intro ML, Intro to Mathematics for ML, you'll see I had especially done what is called as a Jensen's inequality or Jensen's inequality. I have proved it. It is a 1 class long proof, so I'm not going to do it again. You can look it up again.
Which involves
But I'll give you the intuition of what
convexity,
is.
right?
Yes, we have done convexity last time, but I'll show you what is the intuition here. So it says that I'll just put the equation later on. Say expected value of f of x and f of expected value of x. If you have a convex function, that convex function we have proved last time, they have to be facing upwards, right? Like this, we proved last time. This is the convex function. Now, if I take two x's, x1 and x2, right? Just draw it for simplicity on the top. Okay, these two are x1 and x2. So do you agree? This is your f of x1 and this is f of x2. Yes or no? Am I audible?
Yes, sir.
So now what can we say? The average of f of x1 and x2, that is expected value of f of x, sort of average of f of x1 and x2. This is the exact intuition you use to prove Jensen's inequality. You can see the average of them have to lie above the function value at the average, yes or no? Let me write x average. X average equal to x1 plus x2 by 2. And this is f of x. What is it? This is f of x1 plus f of x2 by 2. Okay. Is it okay to everyone?
Yes, sir.
So the function value, do you see it's below the, so do you see that f of x average is less than f of x1 plus f of x2 by 2? Clearly from this graph?
Yes.
This is x1, this is x2. The average is between them. Similarly, this is x1, this is x2, this is x1. This point on the x-axis is x1 plus x2 by 2, and f of that is this point, which is below that f of x1 plus x2 by 2. So that this f of x1 plus f of x2 by 2 is similar to expected value of f of x, right? Yes or no? F is a convex function. If f is a convex function. I'm waiting. This is the only trick you require to show it, and it will be done. Any questions? Okay, so the expected value of the function have to be greater than the function at the expected value at a convex function. So now tell me, what is expected value of log of px by qx? This is equal to, this is scale divergence, yes or no? Correct? Is this okay to everyone? This is the definition?
Yes.
Okay, hello. Now, what is log? Can you tell me? Log is a concave function, right? If you take log of x, take the second derivative, what do you get? Minus 1 by x square, which is less than 0, which is concave function, right? We showed it last time.
Yes.
That if d2f dx2 is greater than 0, it is convex. So if I just multiply minus x, do you agree this will become greater than 0? And this will become like this, convex, right? Minus log x. Correct? This is the hint. Now tell me, what will I make? What will I do to the interior of the expectation? Correct? Is it okay? Yes. Now it is a convex function. What can I do? Expected value of f of x, I can write as Jensen's inequality minus log of expected value of qx by px. What is expected value of qx by px? According to p distribution, it is integral of px qx by px dx, right? What is it?
1.
1. So this becomes 0. Right? So KL divergence have to be greater than 0. Clear? The minima is reached when they are equal. Clear to everyone? We proved it. Now we have to show the last thing. So number 3 we have shown from in some books, they show it this way. But number 2 we can show that minimizing KL divergence is equivalent to doing maximum likelihood estimation. So how will we show that? We have some space. Okay, we have minimize last thing KL divergence is equivalent to maximizing is equivalent to MLE. How can I show that? So let me just define the KL divergence. What is the two distributions you want? Px. And be very careful. Remember that dKL is not symmetric. Therefore, you have to always use this formulations. Clearly see dKL PQ is integral of Px log of Px by Qx dx, which is not equal to Qx log of Qx by Px dx, right? Right? Yes or no? Here the expectation is over P, here it is over Q. So it's not equal by definition. Okay. So this is what I want to minimize. Minimize scale divergence. So what can I write this scale divergence as? I can write this as Px expected value of x log of yes or no? I can write this by the definition. Theta star is equal to argmin of this is equal to argmin of this argmin of this. So what is this? You will have x px log px dx minus x px log of p of x given theta dx. Yes or no? Agreed? Am I audible?
Yes, sir.
Is this so? So this is known as entropy of x. We'll see why is it called entropy later, but it is constant, right? Entropy of x, but independent of theta. Yes or no? Do you agree? So I can just drop this term. So this is equivalent to argmin of theta minus or the expected value of, again I'm writing, yeah, argmin of minus log of x given theta. Yes or no? Is this becoming very similar? Which is also equal to argmax of expected value of log of p of x given theta, correct? ठीक ना भूल?
Yes, yes.
So now I do not know the expectation, right? Expectation is over the data distribution. So how will I compute? I do not know the actual value. What do I know? Samples from the distribution, right? So how will I calculate the expectation? Only samples known. How will I calculate? 1 by n summation of I equal to 1 to n log of. Yes or no? Not okay? Which is equivalent to MLE. Yes or no? Is it clear? Any question? I'll stop here. I'll ask any questions related to this or anything that we discussed. I'll wait for a minute before I stop. Any questions? Everybody was following up to KL divergence thing. Is the application of KL divergence to get theta clear to everyone? So this will guarantee that you will do a maximum likelihood estimate. That's clear to everybody. You will take, the takeaway is, you will take this theta, you will try to move that other distribution Q, whatever, or Px given theta. You can look at any geometry you want. I have given you two different geometries, one in which you move the distribution you are learning towards the data distribution, like here, yes, like here, or you just try to estimate theta star based on the conditional density or the class conditional density, which is data, or here it's the parameter conditional density, where you will get the appropriate theta. Both are MLE, and so we learned today, when we put constraints on the theta by using our beliefs, like we put like an L2 regularization on the ridge regression, on linear regression, we get a ridge regression and so on. Is it clear to everyone? Please solve this linear discriminant analysis solution, and you will be having a better understanding of how things are. Is it okay? Any questions? Okay, if no more, I'll stop recording.